Okay, so welcome to Subnetting from DCOM 101. The purpose of this video is to demonstrate my technique for performing subnetting and to familiarize yourself with the basic principles of doing subnetting problems. There are some assumptions that you understand classes of IP addresses, class A's, B's, C's, that you understand the difference between a classless and a class full IP address. To point out quickly, the default classes for certain addresses are things like this. We have a class A, a class B, and class C. We're not going to worry too much about other classes because it's not relevant when it comes to subnetting. Although there are class D and class E addresses, we're not concerned with those today. It's not the purpose of this video. So by default for class full, what I mean is that you understand the ranges of addresses with these. These are assumed that you understand that the first octet or the first byte of an IPv4 address defines the class. And the reason I wrote 127 here is that's the local host. It's still class A, but it's not usable. You understand this, and then furthermore, that you understand that the subnet mask for each of these by default, in the place of class A's, would be this, class B's would be this, and class C's are this. Okay, that's 255. This is assumed. It's also assumed that you understand what this means, that you know that a subnet mask, sometimes referred to as dotted decimal notation, is referring to the representation of the network bits. It identifies the network portion of an address, which we're going to look at here in a second. So network bits, network portion, okay, always. This is often represented in something called CIDR notation, also called a prefix. So if you see CIDR or prefix, it's the same thing. So what we're doing here is we're simply representing these values in bits. So if I had 255 in binary is 8 bits. Okay? That's why I would write /8 if I was doing the CIDR notation, /8. This is obviously going to be 88 or /16, and for class C's it's /24. Again, CIDR notation, or prefix, or dotted decimal notation, or subnet mask, so many ways to say the same thing, all represent network bits. Okay, so let's move on with this and actually get to some actual subnetting. So what we want to do in the case of a subnetting problem is we're calculating how many networks we want, although sometimes you'll see it worded as how many hosts do we want to have remaining on the network. I'll show you those examples in a minute. But let's just start with something very simple. Let's first have an address. I'll have a little 8 there. Now, this is a subnet ID, or sometimes called a net ID. Okay, this whole thing is a net ID. Again, also called a subnet ID. It is not an IP address that's valid or usable on a network. Okay, I can't use this one. Right? So it's one of the ones that we can't use, and I'll get to the other one in a moment. So that's the net ID. Now, how do we know that's the net ID? Well, we need more information to be able to identify that. So, simply put, in a default situation, we're saying the first 24 bits are network, and the last remaining bits are host. Now, how many bits are remaining? Well, if we say this piece is network, again, that's 8 network bits, 8 network bits, 8 network bits, or 24. We know that a byte is 8 bits. Okay, we should know that for sure. We can see our 24 network bits. We also should know that an IPv4 address is 32 bits long. Okay, because it's 1, 2, 3, 4 bytes. 4 times 8 is 32. So we can say with confidence that this piece here is the host portion, and that means the host bits are 8. So there we have our full 32 bits. 24 and 8 is 32. Now, I'm going to show you 3 little formula, and I'm going to write those right over here, and I'm hoping this is going to be able to be seen. Actually, I'm going to write them on this side. I'm going to write these 3 very important formula, and they are and they're not complicated. So, if I wanted to use these to figure out subnetting, for the fact, the fact of the matter is they work fine with even an unsubnetted problem. If I wanted to use these to figure out how many hosts per network I could have, network progression, the subnet mask, I could. All right, but I want to show you a subnetting example first. First off, understand this is what I call network progression. It's how we are figuring out our next subnet IDs. This one is hosts per network. Okay, how many hosts per network we have. This is to calculate our new subnet mask. So let's do one here. Let's say, for example, I wanted to subnet this into 4 networks. How do we do this? Well, you ask yourself, 2 to what power is going to be greater than or equal to the number of networks requested? And I said 4 just now. So hopefully you know your powers of 2, at least through 2 to the 8th. If you don't, you're really going to want to focus on that because it's very, very difficult if you don't know your powers of 2. You want to think in bits and be able to go from bits to the decimal value and the decimal value back to bits interchangeably at will. So, for my example, I said 4 networks. I immediately think 2 squared is greater than or equal to 4. I need to borrow 2 network bits to make this problem work. So I go back up, and I'm going to borrow, always from left to right. I'm going to borrow, and I'm going to take 2 of these host bits away, and I'm going to make them network bits. That means that I no longer have 8 host bits. I took 2 away. I have 6. Always keeping in mind that there's 8 bits in a byte, so these numbers would have to equal 8. So if this is 4, that's 4. If this is 5, that's 3. And conversely, if the host bits is 4, network bits is 4. If the host bits is 6, the network bits would be 2. Okay? So from here we use our little formula to figure out our new subnet IDs. Now, we progress in the octet we borrowed from every time. We borrowed from the 4th one here, we'll progress in the 4th one here. So 2 squared is 4, so we can identify our next subnet IDs by progressing by 4 in the, look at that. 2 to the H, not N. 2 to the 6th is 64. So I'm progressing by 64, and I'm not doubling it. I know it looks like I just did that, but I didn't. The next one is not 256. I'm adding 2 to the H each time. 192. There are 1, 2, 3, 4 subnet IDs that I just made. Okay? 4 of them. How many hosts per network can I have? 2 to the H minus 2. Now I write total because on class Bs, which we'll look at in a second, it can be that you'll have several network bits left, host bits left here. So you'll have some borrowed here, some here. So you're going to have numbers probably larger than 8. Okay, you don't always have to, but you probably will. So in this simple case, though, of class C, I only have 6 host bits left. And so I say 2 to the 6th minus 2. Well, we just discovered it was 64. 2 to the 6th is 64. minus 2 is 62. And we can easily identify those. Let's look at the first example. I can't use 0 because that's the net ID. So I can start with 1. And I can go through 62. Why can't I use 63? 63 is the broadcast address. Remember, a broadcast address is always the highest possible IP value on a given subnet ID. So for this network here as an example, the highest I can go before I reach the next network would be .191. That is the broadcast address for this network. Let's look at a different case now. Actually, I want to do one more thing, actually. How would I calculate my new subnet mask? Well, we know we start with this. We started with this. We have this to begin with. This is no longer the case here, though, because I borrowed some. So now it's partially network and partially host. So what is it? Well, bearing in mind it's always representing network bits. I could add up the binary values, and that would be fine. But for me, it's much easier to perform one calculation than several. So in other words, I don't want to add 2, 3, 4, 5 numbers together when I can do one subtraction. My analogy for this is I always know how many values I can have for this. So if I know how many there are, it's easier to do a subtraction than an addition. Here's my example. If I know I have 100 apples in a barrel, there's always 100. And I know that there are 3 green ones and the rest are red. I could count up the 97 red ones. I could do 1, 2, 3 and add up the 97 red ones. I would rather just subtract the green, and what I know remains must be the red apples. In this case here, I'm subtracting the host bits from the total, and therefore what must remain must be the network piece. So I simply would say 256 minus 64, and in this case here it's 192. Okay, so this new value becomes 192. So there we have identified our 4 networks, our host per network, our subnet mask, and we identified some broadcast addresses. Let's look at another one. Again, we're going to stick with a Class C. I'll leave this up here. By the way, on that last one, because I borrowed 2 network bits, my new CIDR notation would have been 26. Okay. Let's start back with the default one for a second. Now let's say we'll do one like that. Let's just say that I gave you a different CIDR notation. So I said 27. Remember, this always indicates the network portion. So it's really simple math from here. You know if you start at 24, how many more network bits do you need to get to 27? Well, the answer, of course, would be 3. Because 24 plus 3 is 27. So we now know our network bits here is 3. Leaving how many host bits? Again, 8 bits in a byte. So if I have 3 network bits, then I must have 5 host bits remaining. The rest of it is simply using these little formula again. So my network progression would be 2 to the 5th power, or 32. So my next net ID would be 168.1.32 after the 192. Then 192, 168.1.64, and then 96, and then 128, and so on and so forth, and even 160 in here. Okay, because we're adding 32 each time. We are not doubling it. We are not doubling it. Okay. Broadcast addresses. Again, what's the broadcast address for this network here? The highest value can go before it reaches the network. Next one would be .95, so that's the broadcast address. How many hosts per network can we have? 2 to the 5th, 32. Minus 2 is 30. And again, we can see in the first example, I can't use 0, and I can't use 31 because that's the broadcast address. I can use 1 through 30, and there are 30 IP addresses that I can use. My new subnet mask is going to be 255, 255, 255, dot 256 minus 32, 224. Let's do a harder one, but not really that much harder. Let's do a Class C. Now, Class C's, we already know Class C's. Let's just do, how about 152? Sure, that works for me, right? 152.20.0.0. We know, again, we're starting with the default Class C. At this point, the problem is pretty similar to the other one. I just want to know how many networks I can make, or I'll give you a CIDR notation. I may even give you a mask, which again, if I gave you a mask, the problem has worked very much like the others that you did, except you're just going to do something in reverse here. So if I did this for a mask, we know this is where we derive that. So I would simply do 256 minus this. That gives us our 2 to the h is 16. We know then h equals 4. And would also be 4 that we borrowed, and so on and so forth. It's very simple. You simply take 256 minus the mask, and that gives you your 2 to the h, okay? That's a pretty simple one. I'm not going to get too much into that. Let me continue on with this problem. So let's just say we want to make 50 networks out of this. 50. Remember, 2 to what power is greater than or equal to the number of networks I want? In this case, 50. At this point, all I need to do is think in my head, okay, how many bits is that? Okay, 2 to the 4th is 16, 2 to the 5th, 32, that's not enough. 2 to the 6th, though, 2 to the 6th power is greater than or equal to 50. So I'm going to borrow 6 network bits. Now, just to make sure we're clear on this, in Class B, this is network, right? This /16. And the remaining 2 octets are host. So I'm borrowing from here. Okay, I'm borrowing from this here. So I just identified this problem. I'm going to borrow 6 network bits because that gives me my 50 networks. It actually gives me 64. And I have 2 remaining. Why? How many bits in a byte? 8. 6 and 2 is 8. Now, I have some host bits here I never touched. This is important when we talk about our total hosts per network. I never touched any of those. So I still have 8 remaining. What's my new CIDR notation going to be, or prefix? Well, I started with 16. How many more network bits did I borrow? 6 more. 16 plus 6 is 22. 22. What are my new net IDs? Well, the next one will be 152.20.2 squared is 4. And then the next one will be 8. 12, not 16. We're not doubling it, we're adding it. 16. And then you get a 20 even down here, etc. Until you come up with 64. Starting with this one being the first one. Total hosts per network, total number of host bits left. I have 2 here I did not touch. I have 8 here. I have 10 left. You could have also subtracted the total number of bits in an IPv4 address from the network bits, and what must remain is the host bits. 2 to the 10th power happens to be 1024. We have to subtract 2 because we can't use the net ID or the broadcast. 1022 hosts per network in this example. Let's identify the broadcast address for just a second. The broadcast address for Class B sometimes tricks people a little bit. They come up with this part pretty easily. They usually come up with, oh, I know it's 152.20.7 because as high as I can get before I get to 8 is 7, but they have trouble with the last octet. If you just remember, it's always the largest possible IP address on a given network. If you have all 8 bits available to you, right? They're all host bits, no network bits. If you have the whole range, how high can you go? Well, we talked about it earlier. 8 bits at the beginning of this is 255. That's as high as I can go. I can't go any higher Otherwise, I have to make this a 0 and add 1 to that, like an odometer rolling over. When you get to 999, you've got to go to 1,000 and make the rest zeros. Same thing here. I make this an 8, that becomes a 0, and that is our next network, so that's the highest we can go. Okay. The broadcast address is calculated the exact same way, excuse me, not broadcast. The subnet mask, excuse me, is calculated the same way. We know we started with 255, 255, except for this time we were borrowing from third octet. So we know the last one's 0, we have to figure out this one. 2 squared is 4, 256 minus 4 is 252. Real easy stuff. Remember, if I gave you this, it's just going backwards from that. Would mean 2 to the h equals 4, h equals 2, and so on and so forth. Okay. So that is a crash course in subnetting. Hope you can pause this, rewind it if you need to, but remember these 3 things here and you can do any problem. Subnet mask, host per network, and I call it network progression. Some people refer to it as the magic number, but really the only time you really use it by itself is to show what subnet IDs you have. So the progression of the subnet IDs, progression of the networks. Otherwise, it's not really used except for other calculations where it means different things. Okay, that's why I call it that. Hope you found this helpful. Let me know if you have any questions, if you can get a hold of me if you're one of my students. If not, if you're watching this on YouTube or somewhere else, hope this was one more way that you did subnetting, and hopefully a short and sweet method without all that crazy binary, without all the charts, without drawing magic number things. 3 simple things are all you need.